Thank you. Okay. Yeah, so I'm Lauren. Met me already. So this is creating a gridded data set for the active airborne data. So this was research that Rodrigo started. Um, so myself and some of the other group members have hopped on to help finish this project because we do feel like it is a very important aspect and value add to Activate. So kind of some of the motivation. Um, we know, especially for uh, people not familiar with airborne data, it can be a high barrier of entry to get into airborne data. There's a lot of file formats that people are not familiar with. Like from my background, it was just NetCDF. So when I saw like a .ict, I was like, what's that? It took me months to figure out how to open it. Um, and a lot of students, especially, are like in a similar situation to me. So this was kind of um, from the idea to grid this data to make it in a format that's more accessible to some of the wider end users. And NASA has also kind of recognized this because they had an airborne field data workshop in 2022. And so some of the recommendations were talking about making this airborne data and field campaign data more accessible. Also want to note specifically the kind of format conversion from the iCart to the NetCDF. That's really important. So kind of just very quickly, just give you kind of like our first idea to take care of this data. So this was like the idea that Rodrigo was working on, was to process all the data files from the instruments because they're all in these multiple files across for all the instruments. And so we wanted to have a uniform file format, NetCDF4. And then we thought, okay, now that we have a familiar file format, same time, we could then co-locate the data between the King Air and the Falcon. And then we'd be able to grid that data and save it in NetCDF format. So this was the co-location algorithm schematic that Rodrigo had created. So the co-location was very complicated, at least how we were doing it. And I do want to point out that Joe recently did some co-location for those two platforms. So we kind of went back to the drawing board. Um, think how we could rethink this co-location algorithm or what we needed. And then we kind of came to the realization that we don't actually need to do the co-location for the gridding if we process the data files into that NetCDF with a similar time format. And then if we just grid each of the individual aircraft and instruments, then we would have the data in a grid. So kind of like loosely how we do that. And I'm happy to get into like more details, but this is just kind of hopefully spark some discussion. We're still working on this, so happy for feedback and input. But essentially, we just created the grid that we wanted for the time, latitude, and longitude, filled that with NANDs, and then we looked for each of that variables, and we identified all the points that fit into that grid box with each of the time steps. Then we averaged that data and we saved it to the NetCDF. So it sounds pretty simple, but it definitely was a lot of lines of code. It definitely took a lot of time and a lot of efforts from everyone. So then kind of some of our proposed final products. One data set is going to be the 1 degree spatial resolution. So that's going to be a 15-minute temporal resolution. So that's what is shown here. So we were able to manage to grid one file for HSRL2 for the 1 degree data and Falcon for 1 degree data. So this is what you're seeing. You're seeing cloud top height from HSRL2 because that's a variable I'm familiar with. So that's what I plotted. And this is 15 minutes. And this is the 1 degree. Started working on the 0.1, the 0.01 spatial resolution, but I ran into a memory error when I tried to run it on my computer. So I'm learning about making my code more efficient and how to handle big data sets. So I'm currently working on getting that code ready to run on our HPC. So that data isn't coming, that's why it's not available here. And then the goal is to produce this for HSRL2, Falcon, and the RSP data. So that's just kind of the update. The 1 degree data for HSRL2 and Falcon are not, I won't say good to go because I still have to run all of the dates. And, I say it's going to be good to go and then I'm going to run into a coding error and it's going to take me months or something's not going to work. So I'm not going to jinx myself. But plans to do the 0.1 and 0.01 degree grid data next. And this would be for 2020 through 2022, so for all field campaign data. So for that was just kind of meant to be brief update. If anyone has any questions or feedback, take that.
So the first question is, I know iCar has a learning curve. I agree. At the same time, I want to ask you, did you look at the NetCDF merge file from 2020 campaign?
So in an effort to kind of reuse all of, so to answer your question, no, but in an effort to reuse or use Rodrigo's work, he had already done the first step of taking the iCart and moving it to a NetCDF. Just use those scripts to generate.
Okay, so you might want to take a look, see if that was to save you some time.
Okay.
The second question, the second comment is when you do grading, I think the biggest issue is the temporal and the spatial coverage. Temporal probably is somewhat easier. The spatial coverage with the flight track, that needs to be some consideration to be made, right? So make sure the aircraft data is representative of the grid. The last thing is I will make a general comment on the NetCDF. When I first learned that NetCDF, people says it's great, right? It is great. However, it needs a template. So Brian and Armin and Rob, right? And we are in this working group trying and pushed by Arlindo and Jeff Reed, trying to get some template reasonable for aircraft data, for special for the in situ data. So this is part of the reason I asked, did you look at it? Our NetCDF file in the first question, right? Because if you have a problem, please let us know. We can improve it, right? And also, this is not only going to be for one group. This is generally for the modeling group community. So that's all. Thank you for your presentation. Thank you.
So Lauren, are you carrying any like other statistics other than just the averages? Are you carrying like how many points were averaged, what the min max, maybe what the median might be? I mean,
yeah, in Rodrigo's original draft and the original plan was to include standard deviation. So we're gonna definitely include the standard deviation as well. We could include like the counts or the mean, the min, the max. Yeah,
it might be very critical to know that you have 1 point.
Yeah.
Or thousands.
Yeah. Mm-hmm. Okay, thank you.
For anything radiation related, it's really helpful to not just have an arithmetic mean, but also to have a geometric mean. Because things like optical depth, a geometric mean is much more closely related to the net albedo than the arithmetic mean is.
Okay, thank you.
I would totally agree with Brian's comment. For many parameters, you cannot just simply average it.
Yeah, thank you.
Brian, this question actually more for you, because the RSP, I know the aerosol retrievals would benefit more if you were to, let's say, do the retrieval on an averaged grid size than to do an averaging of retrieved RSP data. I'm curious if that's something that you've considered, like instead of like doing an average of the retrieved effective radius, for example, doing a retrieval based on the data that was gathered from the RSP during that time.
So at this kind of gridding, that would be a no, because generally the plane is turned around and the viewing geometry is going to be different, and the uncertainties in any given viewing geometry vary. So it's really a case of averaging the data and including the uncertainties in the data as part of the averaging process. So you don't take a regular mean, you do a weighted mean based on the variance of each given measurement.